plus 40 square roots of 3. I multiply this next piece, I get minus 6 square roots of 6 minus 20 square root. I'm going to just write 6 times 3. And I'm writing that because I could write 18, but then I'm going to go back and say, well, two numbers that multiply 18. Well, 6 times 3 works, so that's what I'm going to use. And I'll break it down one more time into 2 times 3 times 3. Notice I'm not doing anything else here. We could write all of that down and bring it down, but you don't necessarily have to. Now, this comes out in front as a 3. And so I'm going to go times 3. And now I'm going to write this whole dang thing out. So I got 12 plus 40 square root of 3 minus 6 square roots of 6 minus 60 square root of 2. Now, if you had Miss Wolwinski yesterday, this right here is the same thing as the factor tree going down. I'm just writing my numbers in line instead of going down with roots. Does that make sense? Yeah. Okay. So that's what's going on, and this is going to be your final answer.
That's long.
It is long.
We're getting to that portion.
Other questions from the whole?
What is that question?
Sorry, could you do 18 from 11.1?
Sure. So 18 from 11.1. So for 18, it does say you can use a calculator on the last step, and that's because I take the cube root of 125, which is 5, but then I have to raise it to the 5th power. And so that's the calculator portion. That's the hint on your pack. So you just type 5 to the 5th power, and you got your answer. Other homework problems. All right, I'll just remind you one last time, since we had a few people kind of sneaking in here. Your homework, 11.1 through 11.3, we're stamping that on Friday. Whenever you have class, that's when it's due. You will have a little bit of time to work today, so hopefully you can get the majority of that done and be ready to go for that. And then we have an activity that will do the rest of class. You are not turning in your packet. We will have a stamp sheet. You just have it right next to your packet. Flip really quick. I'll just walk through the rows. Stamp. Ms. Wolwinski will do the same thing. Okay? And you just turn in the stamp sheet. Okay. Then you can go ahead and open up to 11.3. Now yesterday we did addition, subtraction, multiplying, but not division. That's because division gets a day just for itself. So there's a couple things that we look for when we are looking at radicals. You don't want to have any perfect squares or cubes other than one inside the radical. So if you give me an answer as the square root of 4 divided by 15, that better become a 2, right? We got to simplify. So that's what our first restriction is talking about. 2, no fractions under the radical. So we tend to get rid of those, and we do that naturally when we are tackling number 3. This one is the most important one, and I say it's the most important because it's where the most points lie. If you don't deal with number 3, you can lose all of the points in the problem. If you don't deal with number 1, it's probably like a half point because you didn't simplify. So number 3 is the most important, and we're going to see how this works today. We're going to skip over these first two things. Number 1, the first thing I do is actually split that fraction. So when we're multiplying things together, I normally take two radicals and actually put them together as one. Here, when we're dividing, we split. We are going to want to have 2. So I got square root of 3 divided by square root of 2. Can I take the square root of 3? Can I take the square root of 2? So the good news is I am basically simplified in the context there's no perfect squares there. But I'm failing my third requirement, which is that I cannot have a radical right there. We got to get rid of that radical. And my little corny analogy here is that we are going to multiply this by 1. Don't write that down. We're going to multiply this by 1. If I multiply that by that one right there, what happens? Nothing. I get square root of 3 divided by square root of 2. So this is my analogy. We're going to multiply this by 1, but it's the number 1 going to prom. It's all fancy. Okay? So it's kind of like you right now. You're that one just sitting here. I'm just kidding. And the rest of you get all dressed up and then change. So this is what we have to do. I can multiply this by 2 divided by 2, right? That would be 1. I could multiply it by 10 squared divided by 10 squared. It doesn't matter what I do as long as the top and the bottom of my fraction are the same. Because if they're the same, it's just 1. Fancy looking 1. We're manipulating our problem, but it's still 1. So we are going to take a look at what is down here. I don't care about the top. There's no requirement for the top. The top can be as ugly as whatever. The bottom cannot have a radical though. So we're going to use, I'm going to grab I'll do it on the whiteboard. We're going to use something you've done for a while. If you had the square root of x equals 10, and I asked you to solve that, you would say, I'm going to square that. Cancel that out, square the other side. So our 1 is going to make this a square. And by doing that, I'm going to times this by square root of 2. Because when I do that, that becomes the square root of 2 squared. What you do to the bottom, you have to do to the top. So I'm going to put a square root of 2 up there. This is just a fancy 1. And you'll see as we go, this actually looks kind of bad, but it doesn't end up being that bad. So let's just see how it plays out. If I multiply the top together, I get square root of 3 times square root of 2, leaving me with square root of 6. If I multiply the bottom together, what do I get? I get square root of 2 times square root of 2, which is square root of 4. What is the square root of 4? 2. That's where the magic happens. So some people will just go ahead and write 2 there. And I'm fine with that. Some people will write this step and then write 2. Or they will actually just multiply and put a square root of 4 there and then go ahead and put 2. I don't care what you show. I'm probably going to show this as we keep going just to kind of keep reminding you. But again, I don't require that. So all we are doing right here is simplifying. That is simplified. That's your answer. That's half of what we're doing today. I'll take questions after we do one more of these. All right? We are going to do number 2, but we're going to skip over it. We're going to take a look at number 3. Number 3 is looking at a cube root, and it doesn't change the process. I still cut them in half. So I'm going to have the cube root of x divided by the cube root of 3. For something to come outside of a cube root, you need 3 of a kind. I have 1 3. So that means I need how many more 3s?
2.
2 more 3s.
You have to multiply by 1 2 times.
So I'm going to multiply by my denominator. I only care about the denominator, don't care about the top. And I'm going to times it by 3 times 3. You could also multiply by 9, right? I'm just showing that I have 3 3s. Okay, that's all I'm really going for. But on the top, I'll write the same thing. But again, you could write 9 if you want. It doesn't matter. So let's look at how this plays out. For the top, I'm going to show one additional step. So I'll put an A right here because it's an additional step. And this is going to be the cube root of 9x squared, or just 9x. And then on the bottom, I'm going to have the cube root 27. And I say this is additional because you could actually go straight to your answer from this. So the top does not reduce, it doesn't change, it is just the cube root of 9x. The bottom simply becomes 3. That is going to be the simplified piece. Questions? What's the square root of 8?
Two times.
Sure.
2 is the next step.
So it's square root of 4 times square root of 2. So it does become 2 square roots of 2. So this one does show up a lot. So most of the time I would require all the work to be shown of how you get that. But square root of 8, you see it so often, I'm actually okay if you just put 2 square roots of 2. Because of that, we can change this problem and just put 2 square roots of 2 in our denominator. But we are going to go ahead and split this, just like we normally would. And then I'm going to have 2 square roots of 2. Now, someone in the last class asked, well, can I leave it as square root of 8 and then at the very end simplify everything? Yes. All right. But it goes back to my reasoning in the beginning. I'm going to simplify right off the bat because then I deal with smaller numbers and we're less likely to make a mistake later on. Do I care about the square root of 5? No. I don't care about my numerator at all. I don't actually care about this 2 either, because that 2 right there, there's nothing illegal about that. That 2 is completely fine. I only care about this radical. So, when I choose to multiply, I'm going to only choose actually to multiply by the same thing I did here, by the square root of 2. So let's do that. Square root of 2, square root of 2. The top gives me the square root of 10. The bottom is going to give me 2 times the square root of 4. Again, that's an additional step. We know that the square root of 4 is going to be 2, so I'll cross it off, put times 2, leaving me with the square root of 10 divided by 4. Questions? You get to do number 4, and if you take more than 2 minutes, you're thinking way too hard. Try number 4. Recognize one thing. That's really good. Square root of 100, what is it? Yeah. So that's the most important piece. Okay. So this problem actually does not fail requirement number 3. This is square root of 8 divided by 10. If you got that, it's not done, but you did good. Square root of 8, I just told you up here, is always going to be, and I'll just show it really quick. I get 4 times 2. So then this becomes 2 on the outside. So this is going to be 2 square roots of 2 over 10. If you got that, you're doing a little bit better, but it's still not done. And it's not done because of this. If you gave me an answer as x equals 2 divided by 10, would I accept that answer? No, because what is 2 divided by 10? 1/5. Yeah. So just like with this, we have to simplify, we also have to simplify here. Okay? And this gets tricky because we're so focused on everything else that's going on, we sometimes forget about that. So if you got here, really good job, but you do have to cross that off and go square root of 2. And if you want to put the 1 in front, you can. And this would be divided by 5. This is our final answer. Questions? Number 5. It's a 4th root. So how many 5s do I need to get out of there? I have 1, so how many more 5s do I need to get out of there? We need 3 more. So I'm going to times this by the 4th root of 5 times 5 times 5 to the top and the bottom. Now I'm going to do most of this one, so I get 10 4th roots off of 125. The bottom here, I got 1, 2, 3, 4, just becomes 5. Do the last step and simplify that. Radical stays, nothing gets simplified in there. It's just the numbers on the outside that you have to deal with. So we get 10 divided by 5, just gives you 2. And then that 2 sits on the outside and 4th root of 125. That's stuff. Questions? We're not going to do 6. You can actually go ahead and flip backwards to 11, 2. We're going to take a look at 9 and 10. And we're going to we're going to revisit a concept. So I will kind of work through number 9 with you. We're just going to talk about some stuff that happens. So I double distribute. And so I get 7 times 7. I put 49 down. What's 7 times negative square root of 3? So this is 11, 2 again. We're looking at problem number 9. So 7 times negative square root of 3.
Negative 7 times square root of 3.
Yeah. So actually the question is also the answer. So we get that. I do the next one, so 7 times square root of 3 is 7 times the square root of 3. This last piece also throws people for a loop. So when you look at the square root of 3 times negative square root of 3,
You get the negative square root.
correct. So we get negative square root of 9, and really that just becomes 3, right? So I'm going to get minus 3, and let's look at what happens. Our items in the middle cancel out. We have the same amount of the same thing. It's like I have negative 7x and positive 7x. So those are gone. So I'm left only with 49 minus 3, leaving me with 46. I started with radicals. I started with square roots. Now I don't have any square roots. We'll talk about that momentarily. Go ahead and do number 10. Same thing happened again. What are these called? No. Some of you are looking at the wall and you're smart to do so. It's right above me. It's a conjugate. It is the difference of perfect squares, but they are conjugates. So we have a plus and we have a minus. We have the same exact numbers. We have a minus and a plus, same exact numbers. You've used this before. You've used this back in
Was it unit 5?
Unit 3, which is in October-ish. And so we used this for problems like this. You would get something like 7 plus 3i times 7 minus 3i. And it would get rid of I for us. Now it's doing something similar. It's getting rid of a square root for us, or it's getting rid of a cube root for us, or something along those lines. So, not actually a cube root, just the square root. So, when we look at this, you can now flip back to 11.3. We're looking at 7 and 8. This is different than the first page, all right? So the first page, there's no addition, there's no subtraction. Now we have addition and subtraction. In the first page, when we had like 3 square roots of 2, I didn't care about the 3 in the front. I only cared about the square root of 2. Now, that doesn't work. I have to use this whole thing. I have to use the conjugate to get rid of it. So we're going to do one of these together, and then you're going to try one. Notice I put a lot of parentheses here. You should too. I told you the same thing in chapter 3. Put lots and lots of parentheses. Don't do anything without parentheses.
We want one.
Yes. So we're going to use the conjugate, which means we are going to have 3 minus square root of 2. Now, I don't mind if you use the conjugate shortcut and you look at that and you might throw 7 out as an answer. That's fine. But don't get too comfortable with that, because anytime you have to distribute, it only works for conjugates to do that little trick. If there's any like a plus and a plus, it doesn't work. So you have to just be careful when you're using it. If I look at the top of this fraction, I'm going to get 6, and then I get another distribution. I get minus 2 square roots of 2. One mistake I've seen people make today is they just go ahead and get rid of that subtraction symbol. And they just group it together and they say, that is 12 square roots of 2.
No.
No, it is not. So please don't do that. Over here, on the bottom, I'm okay again if you jump to the end, but I will work through it. So I get 9 minus 3 square root of 2. That's distributing the first two items. Then the next two items gives me plus 3 square roots of 2 minus 2. Because again, square root of 2 times square root of 2 with the minus sign in front gives me square root of negative 4, which is just that 2. So I got a minus there. The final answer then becomes this. It's really just 9 minus 2. So I get 7 down there. I want you to take this, and I want you to change the 7 to an 8 down below. So for problem 9, we're not going to do 9, you can cross it off. I just want you to take this answer, though, and write it like this. So again, do not put this next to our solution. That's completely different. We are just going to work on solving something like this, because this I can reduce. I can deal with the 6, the 2 outside the radical, and the 8. I don't deal with what's inside the radical. I'm not changing anything up there. So if I look at 6 and 8 and the minus 2 square root of 2, this is the same thing as 6 divided by 8 minus 2 square roots of 2 divided by 8. This 8 does not go to one of them. It goes to both. And I've seen a lot of people make that mistake too. So when we reduce here, this becomes 3/4 minus, this will be 1/4. Keep the square root of 2 up there, like that. You could also write it like that, because they have the same denominator. That's just food for thought, because you will have to reduce them later on. Questions? What is the conjugate of number 10? Next. We're going to do that one. So I'm going to multiply this by 4 minus square root of 5. Oh, not 2. And times it on the top by 4 square root of 5. Put in parentheses everywhere. You try this one. Multiply the top, and then multiply the bottom. Bless you. Did we get it? Okay, why is it? Okay. That just comes from that minus sign right there. Whatever that sign is, just sticks there. So if it was a plus, then it would stay a plus for the other problems it was. So, other questions? Go ahead and open your note packets up, or your homework packets up. We're going to do number 1 together. It's actually the hardest problem. So we'll get that one done, and then you get time to work through the rest. So this is 11.3, number 1. All right, what's one thing you know without really doing any work? Square root of 4. Yeah. So we can just cross this off and just put times 2. So right off the bat, I got 4. I'm not going to write the bottom yet. We're going to do a little bit of work with the bottom. So I just have 4 on top. That's a little bit easier than dealing with another square root. Now, you could take this, put it right there, and then go multiply by the square root of 12. But since we are reducing, let's reduce all the way. 12, I can break down to 4 times 3. This one shows up a lot, and I cross that 4 off, put the 2 out there, and I'm going to be sitting on 6 square roots of 3. Is there any questions about this piece? We're good with that? We're just simplifying right now, making it as small as we can. Questions you should ask yourself. Does the 4 matter? No. Does the 6 matter? No. It's just the square root of 3. Now some of you might be thinking, I could reduce even more, because I can, right? What can I reduce 4 divided by 6 to?
2 divided by 3.
2/3. Okay? If you don't do that right away, it doesn't really matter. What matters is going to be the radical. So I'm going to cross this off, and I'll put 2/3. Like that. And now we shouldn't have to do any simplifying when we're done. So I'm going to multiply this by the radical, which is square root of 3. I'll work through the long version of it. If you go a little bit shorter, that's fine. So this becomes 2 square root of 3 divided by 3 times the square root of 9. So I can cross that square root of 9 out and just make it times 3. That's going to leave you with 2 square roots of 3 divided by 9. So I get to cross off the 9 because we know the square root of 9. Right? That's where this 3 comes from. So if that was the square root of 16, I would also cross it off and just put 4 right there.
Why isn't it 3 times 3?
You can write it like that too. So I could have like 3, and then I could go, well, that's 3 times 3, right? And then that pair gets taken out as a 3.
And then it goes to the square.
It can go to the front or the back. It doesn't matter. So I have been writing it like this. So it'd be 3 times 3 then, right? Did the same thing here, but since I crossed this off, I just imagined that it was gone. So I did 3 times 3. Okay, I did write it differently than the previous ones. Other questions? Number 2, what are you going to times the top and the bottom by? What square root is in the denominator of your fraction? Square root of? For number 2.
Oh.
5. You're going to times the top and the bottom by the fraction, or by the square root of 5. Okay? Now, conjugate, you don't use on this first 4 homework problems. We're going to use them on the bottom 4 homework problems. And we only use the conjugate when I have like a minus sign in the denominator, or if I have a plus sign. If I'm adding a number and a square root together, that's when I'm going to use it. So the first 4 problems are like the problems we did on the front of your note packet. And the last four are like the ones at the end of the notepad. These are kind of weird, so I'm giving you time because I'm expecting questions. I don't expect you to be experts at it already. So go ahead, try it out, and let me know what questions you have.
Is it up back there?
The solution.